All right, so let's go ahead and take this up. This is a quick little solution video, and this actual page will be posted as well. So what you'll see is I finished off that chart that you're supposed to create with different lengths for given a perimeter of 10. And what you should have seen is at an area of 9, that's when you get your maximum area, and that occurred when you had width and length of 3, which are actually equal to each other. So maybe that's a sign of something. And you'll see with your first differences, they were bigger positive numbers, became smaller. Eventually, it would have hit 0. But I mean, we don't have that spot because we're just doing every whole number. And then it becomes negative. So at closest to 0 is at the maximum. And that sort of helps us define where the maximum would be. All right, and then in the next one, we looked at a rectangle with perimeter 14. So again, you could fill out this chart going from 6 all the way to 1. And eventually you'd see you actually get 2 sort of maximum areas when you have a width of 3 and length of 4, and then the other way around. And so what I did is just at the bottom here, I just double checked what's in between the two. And you'll see that you actually get an area of 12.25, so a little bit bigger. So that is actually the maximum area. And again, you'll see 3.5 and 3.5. They're both equal. And that's what's going to be the key finding, is that if you're having a fixed perimeter, so if you know the perimeter and you want to maximize the area, then as long as you make the length and the width equal to each other, that'll maximize the area. And essentially you're just creating a square out of your actual lengths and widths. So that's the first part. And let's just take a quick look at this example. So let's say you're using your findings. Your rectangular yard is being enclosed on 4 sides using 60 centimeters of fencing, or 60 meters, not centimeters. What would the dimensions of the yard with the greatest area be? All right, so we know the length and the width have to equal each other. So what we can do is, since we know the perimeter, we don't want to do 60 divided, but we will be using the number 60. We have, let's say, 2 lengths and 2 widths. So in total, we have about, let's say, if you were to draw it out, you have 4 pieces. And those 4 pieces are all equal, so we can just take 60 divided by 4. And, well, 60 divided by 4, I don't know why I rewrote it there, but I just did, is equal to 15. So each side is 15 meters. So in terms of dimensions, you could write it 15 meters by 15 meters. And that would be our yard with the greatest area. All right, so that was looking at maximizing the area if you had 4 sides to work with. This next one is a little different because you only have 3 sides to work with, because you sort of have one fixed side. So you only have, let's say, 1 length and 2 widths. And if you filled in the chart, you would have started at 9, because 2 widths of 9 would make a perimeter of 18, plus the 2 would give you the 20 that we wanted. And then you just had to figure out the corresponding areas. And what you should have seen is, just going through that, eventually you would reach a maximum of 50 when you had a length of 10 and a width of 2. And what's interesting is that at that point in time, the length is actually double the width. And that is the key to these kinds of questions. So if you only need 3 sides and you have that fixed perimeter or that fixed amount of fencing, whatever it might be, that you're working with for those 3 sides, but you want to maximize the area of a rectangle, well then what you can do is you can just ensure the length is double the width. And in that case, you're just assuming the length is, there's only 1 length and there's 2 widths that you're working with. And that's how you'd go about solving that kind of a problem. And let's just take a look at an example. So let's say we have a rectangular garden that's enclosed on 3 sides with 37 meters of fencing, and we've got a wall on the other side. So, sorry. So let's say we have our wall there, and we're going to be fencing off the other sides. And we already know, based off what we just said, the fenced part should have a length that's double the width. So what we can do is we can label the widths W and W, and we know that length has to be twice that. So we can write it as 2W. And now what we can do is we can go ahead and actually solve for the dimensions that will maximize the actual garden. So how do we do that? Well, we know W, the one width, plus the other width, plus the length, which is twice that. All those 3 pieces together they have to equal 37 meters. All right, so now that we have this set up, we can just go ahead and add or collect those like terms. So we have 4 W's, and you don't have to use the variable W, you could use something else, but that's what I've chosen. And then solve for the W. So again, we want to do the opposite operation, so we'll divide by 4, and that will give us W is equal to 9.25. And while we said the length is twice the width, so the length is just 2 times 9.25, which is just 18.5. And so, therefore the dimensions are 9.25, and let's include some units, meters. I'll throw those units on those answers there, by 18.5, 0 meters. And there we have it. That is the solution to that question.